In this video, they're asking us to solve this radical equation. The procedure to solve a radical equation is first to isolate a radical term. And that is the case here. We have the radical by itself. Next, we'll use the principle of squaring, which is essentially squaring both sides. So we'll square the left side and square the right side. Here we have a binomial times itself. We'll use the FOIL method. On the right, we have a product raised to a power, so each one of those quantities will be squared. So we'll have 4 squared, and the radical squared is the radicand. Simplifying then, we'll use FOIL method. First terms multiplied together is x squared. Outer will give us a 4x. Inner terms another 4x, which are similar terms and combined to be 8x. Last terms multiplied together is 16. On the right, 4 squared is 16. And as I mentioned, anytime you have a radical squared, you have the radicand. Simplifying on the right, we can use distributive property and multiply each of the terms by 16, which leads us to a 16x plus 16. Here we have a quadratic equation, so we will want to put this in standard form, which means everything is on one side of the equal sign. To do that, I'm going to subtract a 16x from each side to eliminate the term here. And while I'm at it, I'm going to also subtract a 16 from both sides to clear the right side. These two terms cancel out. On the left, we have an x squared, combining like terms, a minus 8x, and our constant terms cancel out. To solve this quadratic equation, let's factor. There's a common factor of x, and when factored out, in other words, we're dividing, x squared by x leaves an x, 8x divided by x leaves an 8. And then using our zero product property, when two things multiply together to equal 0, one or the other must equal 0. So one of our possible solution is x equals 0, and adding 8 to both sides, x is equal to 8 for another possible solution. When using the principle of squaring, it's essential that we check all solutions in the original equation. So here we go. Are these in fact solutions? The original equation was x plus 4, so in place of x we'll put a 0 plus 4 was equal to 4 times the square root of x, and we're letting x equal 0 plus 1. And we're going to check and see if we do get a true statement. On the left, 0 plus 4 is 4. On the right, simplifying underneath the radical, we have the square root of 1. The square root of 1 is 1, and 4 times 1 is 4. So true result here. So one of our solutions is 0. Does the other one check? Well, let's replace x with that value, which was 8. So we will have x, which is 8 plus 4. And we're going to test to see if that's equal to 4 times the square root of x, which is 8 plus 1. On the left, we can substitute a value of 12 for that addition. On the right, combining underneath the radical, we will have a 9. Square root of 9 is 3, and 4 times 3 is 12. So we also have a true statement telling us that both of these values are solutions. We will have 0 and 8 in our solution set to this radical equation.